so continuing from yesterday, we were talking about increasing and decreasing intervals at the very end, right? Your problems 25 and 27 had to do with those increasing and decreasing intervals. So the next thing I want to talk about is how do we find maxes and mins? So if my problem doesn't give it to me, what am I going to do? Well, let's not do that. But what I want to remind you of is that, again, we have that technology in front of us, right? If we graph it, and I know you guys remember how to do this, in our graphing calculator, remember that you can go into your graph. Oh, come on. So let's do this. So as a little practice, I want to remind you guys what we can do. Everybody go into y equals and put in, how about x to the third plus 2x minus 5. Yeah, we're going to get, yes. So in the graph I just gave you, what does it look like? Yeah, so in this one, does it have a max or have a min? So this one is increasing the entire time, right? Let's try another one. So let's change our equation to, how about 2x to the third oops, helps if I hit it right. Third. Minus, how about 5x plus 1? All right, so when you graph it, and again, you guys, this is an important part of understanding the calculator. You get a picture that kind of looks like this, right? All right, our goal is to remember how to find this max and this min. So we need to talk about it. First thing we're going to do, everybody is with me. If you don't have a calculator, you should get one. First thing, after you graph it, I want you to go to second and trace. When you go to second and trace, let's start with our maximum, which means you have to go down to 4. Very good. So you're going to go down to number 4, which is the max, and hit enter. Okay, at the bottom it says left bound, which means remember you got to move your cursor to the left side of where the max is. And hit enter. You'll see that imaginary line, so to speak, come up to the left of the max, right? So you have to do left bound. Then once you hit enter, you have to do right bound and hit enter. It just has to be to the right side of where the maximum is. At the bottom of your picture, it says guess with a question mark. What do we do there? Enter one more time. Very good. So we hit enter one more time. And in this case, we got the points, negative 0.912, comma, and 4.40. Oh, yeah, 4.04. All right. There's our maximum. Do you guys remember doing this? Okay, good. So now let's go on and everybody do it again. This time do it with your minimum. Left bound and right bound. Okay? So you're going to repeat for min. So I got the point 0.9128 and negative 2.04. All right. So that's our maxes and mins. Now we're going to use this information to do our increasing and decreasing intervals. Okay? So the real goal is to make sure we remember how to get it out of our calculator. Then we can set our calculator to the side once we have those values. And again, when we do increasing and decreasing, what value do we use? The x value. Very good. So here we go. We're going to start by, what am I first doing? Increasing from negative infinity to negative 0.912. Then what do I do from the max to the min? Decrease from negative 0.912 to positive 0.9128. Then what do I do? Then we increase. Very good. From 0.9128 to infinity. Awesome. Okay? So doing this is what you have to do for 29 through 33. It's not so bad. You look it up, you graph it, you get out the maxes and mins, and you move on. Okay? That's the y values. Technically, those y values are the maximum and minimum of the function. Those are the values of the function. So when we're talking about where the graph is doing things, we always look at x. It's kind of like reading it like a book. You know what I mean? So we're always talking about going this direction across, right? Okay, good question. All right, so are we good there? This is exactly what we're doing for the first two problems. Next thing I want to talk about is, do you guys remember what it meant for the function to be bounded, if I could spell? Or unbounded? Kind of. We're talking about a graph, though. Kind of. Not quite. Kind of. You guys are all on the right track. No, when we talk about the graph, seriously, it's just looking at the picture. If, let's say the picture looks like this, right? It can't go any further down. So we're going to call that this is bounded because it can't go any further below. Right? Because it only goes down to this point, can't go any further, and it goes back up. So it's bounded on the bottom. If I had a graph that went this way, what do you think we'd say? This is bounded above, right? Because the arrows are pointing down. That goes forever. So this is bounded above. What about if I had a picture that looked like this? This is unbounded because it can go forever up and forever down. Oops. Okay? So in the next section, so here's example, technically this is example number 1, technically. And this is 35 through 39. The directions ask you to determine how it is bounded. So those are going to be your 3 options, either above, below, or unbounded. All right, so if I gave you a function that was maybe y equals 2 minus x squared. So you could graph it and look at it. You should be able to look at that equation and know what it is. Anybody got any ideas? Yeah, it's a parabola that opens down, right? And yes, so if it's a parabola that opens down, this is bounded above. Let's do one more, just in case you might get a trickier one in there. What if I gave you something like y equals 2 to the negative x? What do you guys think this one's going to do? All right. Why don't you do that? Yes, so this one is a graph that technically, yeah, it should do this, right? So it's getting closer and closer to 0, but never ever touches it, right? Bounded below. So it's approaching an asymptote, right? It just never ever gets there. Uh-huh. Okay. Above. Yes. Yeah. So let's go back to that for a second. So let's kind of put a star here. If can't go lower. Will that define it okay? Right? So I can't go any lower than that spot. And so then this one, if can't go higher. All right? And if those that function, those arrows go forever up and forever down, then it's unbounded. All right? Does that help, Alex? Okay, good. All right. So, next part. Do you remember when we talked about odd, even, or neither? You're close. Oh, bless you. So let's talk about odd and even functions really quick. Just to remind you, if a function is an odd function, okay, it has, and I want to talk about symmetry first. It is symmetrical about the origin. So, for example, if I have a graph that does this, if I can take my graph, turn it 180 degrees around, and it looks exactly the same, it's odd. Can I take a parabola and turn it 180 degrees? Yeah. So we'll talk about it in a minute. So if a function is even, the function itself is even, then it's symmetrical, and we're going to use what Shelby just suggested in just a second here. It's symmetrical about the y-axis. The origin. Neither? We'll get to that in a second. So even is exactly what Shelby was talking about. If I have a parabola, if I fold it right on that y-axis, will the two sides match up? That makes it an even function. Okay? That's from the picture itself. All right? You might have. You could have, yeah. It's possible. We talked about it a little bit last year. So let's continue. That is doing it graphically. Okay? That is if you look at the graph. If you can rotate it 180 degrees and it looks the same, it's odd. If you can fold it on the y-axis and it looks the same, it's even. If it doesn't work either way, then it's neither, right? So let's just do a couple, and then I want to talk about how to do it. That was graphically. We also have to know how to do it algebraically, right? We always have to do that. So, you could, but your calculator, remember when you take the SAT that some of the questions don't provide you a calculator. Yeah. I know. So, here is, and we'll come back to that in a second. So, tell me, in this picture, is that odd, even, or neither? This is neither. Very good. How about this picture? If I could draw better. That is supposed to be odd. How about this picture? Neither. Good. I was trying to be tricky. How about, whoops. How about this one? It is odd. It is. Right? And one last one. How about if I have it's if I fold it on the y-axis, do the two sides match up? So this is even. Can I take and turn it upside down 180 degrees and does it look the same? No. No, it would be in an M shape, not a W, right? Okay. So from the picture, it's pretty easy to see if something is odd, even, or neither. However, algebraically, got to throw that in there. Yes, ma'am? Oh. Nope, it has nothing to do with that. Yeah, so if I were to take this right here, the whole idea is if I were to rotate it 180 degrees, is it the same? If you assume my drawing's better, it would be the same, right? Whereas here, if I put my finger on the origin and I rotate it 180 degrees, is it even close? No. Right, so it's not around the origin, so it's not odd. And I always remember, odd and origin, they both start with O, right? So it helps you put the two together. Okay, so let's talk about algebraically, though. Got to do one algebraically. Of course we do. So let's go back up here. If a function is odd, if you put negative x in for x, so I'm substituting a negative x in, my whole function turns negative. Okay, so let me do an example of that, and I'll come back to even in a minute. So here's an example. If I have, let's say, y equals x to the third plus x. Okay? If I plug negative x in for x, so I'm going to take this, I'm going to put negative x where x is, and I simplify this, right? Negative x to the third power is negative x to the third, and negative x, obviously times a positive is negative x. Is this function totally opposite the original function? Right? Since it's totally opposite, this is odd. Okay? So what if I had something like this? Let's say I have y equals x to the third plus 2. And I plug negative x in for x. So I have negative x to the third power plus 2. When I simplify this, I get negative x to the third plus 2. Is this whole function the opposite? No, so this would be a neither. Okay? Does anybody need me to clarify that a little more or no? What part of it? Right. So, you understand that you're putting a negative, hey guys, you're putting a negative x in for x, right? That part we got? Okay. So when you simplify it, you get this. If all the signs are opposite, so see how it started off as positive, now it's negative, started off as positive, then it's odd. Okay? All right, let me back up and talk about even. Yep. Put it inside. You replace an x. So let's talk about even. If I have f of, and I put negative x in for x, and my function remains the same. It has not changed when I'm done simplifying. it is even. Okay? So let's try one of those. You guys can see how that works. So let's say I have y equals 2x squared. 2x squared plus 4. All right, so I'm going to put negative x in for x, right? So I have 2 times negative x squared plus 4. Negative x squared becomes positive x squared, right? So I end up with 2x squared plus 4. Are these the same? So that makes it even. Annika. Was there an x? What are you talking about? So what this means is that if I put negative x in for x, it gets the original function back out, okay? Anybody else? Happy to clarify anything we need to do. All right, so let's go to an actual example and see if we can figure out what it is. Sounds good. I agree. All right, so here we go. I am on example 2. That's it. Whoops. All right, so this is what you're doing for 47 through 53. Is it odd, even, or neither? And let's give you a function. How about y equals 3x to the 4th plus 2x squared.
So you got to test all 3 of them, right?
Yeah, you got to put them in both. You're not testing anything, you're putting it into both x's. So when we rewrite this, we have 3, where that x is going to be a negative x to the 4th, plus 2, where that x is, we put a negative x squared. We just replace x with negative x. Now we simplify. Negative x to the 4th power becomes 3x to the 4th plus 2x squared. Is it the same function? So this is even. That's how we're doing. Sorry, excuse me. Hello? Yes, I can do that. Yeah, bye. Sam, Mom's on her way to pick you up. We're going to do 29 through 61. Odd. It is not that many. No. All right. So are we good with odd, even, or neither? The homework is going to be on page 95. 29. Says, hey guys, 29 to 61, odd. Okay? 29 to 61, page 95. Same page we were on before. I have that page posted in Google Classroom. 29 through 61. Huh? Odd. Odd. Yes. Guys, hey, please. I'm not done. Go ahead and have a seat. No, I'm not done. All right, so let's finish up. So we've talked about odd, even, or neither, which took us all the way to 53. Last example then. Example number 3. Because I think we all remember how to do this section. I don't think we need to do more than one example. This is going to cover your 55 through 61. The remaining part. Find vertical and horizontal. I heard that's easy. Yay. Asymptotes. All right, here we go. Of course, You got to do some factoring. Knew you would. Huh? So let's go with y equals. How about something like x squared plus 4 over x squared minus 1? So the first thing we have to do before we can decide on vertical, yes, I forgot a T in there, vertical and horizontal asymptotes is first, let's factor everywhere. We only need to factor the denominator to start with. That happens to be the what? Very good. It's the difference of squares. So this is x plus 1 and x minus 1. So I have vertical asymptotes at x equals, good, and x equals positive 1. These are our vertical asymptotes, right? It's whatever makes the denominator 0. Do we need to clarify vertical asymptotes at all? We're good. All right, awesome. Horizontal asymptote, it's 1. I agree, remember your horizontal asymptote. You take your highest degree, which in this case is x squared, and you take the coefficient. This is y equals 1x squared, or 1 over 1x squared. So we have a horizontal asymptote at y equals 1. Oh yeah, right? We're good? Anybody need me to clarify that further? No. Not today, anyway.
That's all right. We live like one day at a time.
Okay. All right. So, somebody over by the board, if you would like to add on that it went to 61 instead of to be decided or determined, that would be awesome.